Thank you for having me. Thank you, the organizers, the Elastic Meetup organizers, and thank you all for coming. Today, we're going to be talking about the experience, one of the latest experience that we have had with a client, putting the whole Elastic stack onto the cluster on Kubernetes, more about Azure AKS. As I was saying, so the idea is to going through the different stages and deployment scenarios that we have to basically go through in order to have the full installation stack. But I wanted to first give a heads up about a bit of a context in terms of monitoring and logging and what these days called the observability. Okay, so we'll spend like a couple of minutes, up to 5 minutes talking about it. Then we'll go through the details of deploying over Kubernetes, the whole stack, 6.7.1, because this guy's released very quickly. And so we couldn't make it to 7.0, which was released, I believe, a couple of weeks ago, but it shouldn't be a problem, okay? And then finally, we will cover and share with you lessons that we have basically we learned and what should we be doing next, okay? So the idea of this slide is to basically understanding where we are coming from. And so on the left-hand side, we can say the situation or the scenario more common when we were basically developing stuff, where we had big chunks of code rolling onto a single server, and we didn't release that often, and we were basically having the typical monitoring scenarios as we need to check out the CPU usage ratio and processes. We needed to also consider memory, disk throughput IO, and also network. Okay, so basically the challenge that we had at this point was we had to install stuff via agents in order to have to start profiling this information using a number of tools. So we had to use these, let's say, manual way of installing what we call agents, so then we can have this information. And we were very, I would say, lucky if we had in place some automation tools, as for instance, Chef, Puppet, or Ansible. I'm more like of Ansible, but anyways. But on the scenario even that we have evolved onto this distributed way of designing software, where we have what we can say microservices or little chunks of code that they have their own life cycle, and they are basically following this principle of loosely coupled deployment and communications, and they are basically very rapidly and quickly being updated. And we have a number of servers that we need to manage. So if we add on top of these a situation where we have a number of projects that are running across the different environments with different CI/CD pipelines, then we have a problem, because we need to have a way of automating and automatically discovering these metrics under the hood. So then if we are coming from this, let's say, monolithic way of building software where we have to manually be adding agents, so then we can finally onto the container side of it, then we have to basically be talking about Kubernetes. And the reason that's why I basically, Kubernetes is something that has come to stay. And I will say that is the new kernel for the operating systems. Kubernetes is basically super buzzy and super trendy these days. How many of you have used or is using Kubernetes? Okay. What version of Kubernetes? If you know? Not specifically know? The latest is 1.14, and there are a number of changes. But anyway, so this is the demo that we're going to be using is on 1.13.5, which is the latest version that AKS is supporting these days. Right. So in terms of Kubernetes, we've got a number of pieces around it, and there is a bit of a chaos in terms of deciding what is the right tooling for monitoring, for logging, or for tracing stuff. Okay. So we need to take some time on understanding what are the alternatives out there. For me, or for us, a very good thing to have in place or into consideration was the Cloud Native Computing Foundation landscape. Do you guys know what this is? CNCF, somewhere around there? Right. Other. And the CNCF is what is bringing, actually, this is a foundation which is backed by the Linux Foundation. The idea is that they are categorizing number of technologies that are solving a specific number of problems. And for us, we are going to be focusing on this side, which is basically the observability and analysis number of products that they are kind of considering these days. For us, observability and analysis, I like to call it observability, is going to be monitoring, logging, and tracing. We are not just covering the chaos engineering, which is something that we could, these guys, I'm pretty sure they will soon. Right, so starting on the monitoring side, there are a number of, so the reason that's why I said order and organizing chaos is because there are a lot of different technologies to solve the same problem. So whenever you are facing the decision-making of what to use, this is a very good place where to start from, because it can give you, you know, the most important pieces that are right now onto the market. For us, because we're open source, we only care about the open source one, okay? And regarding to the monitoring of the time series-based databases, these days, big gun is Prometheus, and also obviously the Elastic stack is not here, and I have to make a stop in here because Elastic became CNCF last December. And I don't know why they are not putting here on monitoring. It will appear only on logging. And for us, at least for a number of my colleagues, was very important to kind of realize that Elastic is more than the typical Elasticsearch, logstash, Kibana. And this is something that we basically need to have very clear about. And then we will see. Cool. I need to not forget that I need to be rolling a automation under the hood because we're going to be doing some demos. I will show you. So I've created the Terraform cluster, and I will show you later, but I wanted to gain some time. And I have deployed Elasticsearch. I just not to forget about it. Anyways, so we got the monitoring number of tools. We got on the logging side, we got the same situation where we have a number of different products that are solving the same problem. Which is basically data chipping logs onto something. So then we can index, and then we can arrange the information, and then we can somehow visually consume it. And as well, we have a number of products, and we care about the open source one. And here is where, on the Elastic side, and I will say that here we go on the logging, what we call the file beat, and for data inches, we go on processing, we've got a logstash. But FluentD is what these days is also a big influence on this side. And then finally, we've got tracing, and not sure if you know about Zipkin or Jaeger. Open tracing is the standard or the factor way of treating this information throughout different services. There are different category, which is on the big landscape, which is the service meshes categories that are basically treating in a different OC level the logs using gRPC. So we got ISI, we got Kiali, and these guys are using Jaeger, which is a different way of treating logs with CDK and proxy. So if you guys want to talk to it about it, we can have a discussion later. Cool. This was a pre-introduction that I wanted to do about where we are coming from before jumping onto what the scenario that we're going to be discussing today is. So the idea of this client is that they wanted to evaluate what were the pros and the cons of using the stack, open source. And we're going to be talking about all the open source features. We're going to be covering like machine learning and a number of different under licensing features, but the idea was, or they wanted to basically using Azure and using AKS, they wanted to roll out over Kubernetes the full stack of the solution. This is the stack we're going to be deploying, and the first piece is going to be showing very quickly how to deploy the infrastructure on Azure, and we use Terraform. How many of you guys have used Terraform and know about it? Pretty sure most of you are. So it's a very well documented effort from the Terraform guy, from the HashiCorp guys. The idea is basically, I'll show you in a minute, it's just basically creating a couple of resources, binding with different variables, so then we can do the dynamically binding of properties. And I I didn't know about the internet connection, so I run the thingy before coming here, and I don't know why I got to stop it, so then I can transition to the other one. Sorry about this. Anyway, so basically what we did was deploying with Terraform stuff, and the structure of this guy is second. Right, so the Terraform is just very easy. We've got this main class, which is basically we create a resource called a Azure Kubernetes cluster. We've got a number of properties, so then we can allocate on which AZ we want to have it, if we want our bag, and so on and so forth. Nothing really fancy here. We're using the Azure provider. Actually, you guys, okay, and we just basically got it rolling, and we got it running. Okay, so what I'm going to show you here is so I'm using this super cool tool named K9S. I don't know if you guys have heard about this. This is basically a client that's talking to the API server of Kubernetes. Is basically retrieving information about what's happening. So yeah, I've also anticipated deploying Elasticsearch, but we're going to be deploying one by one all the services, okay? Right, so we did deploy Terraform on an automated way. And also we're going to be, we just deploy Elasticsearch. So pieces that are important or needed to be considered are that we are going to run the just one node cluster a topology, and we are basically having a stateful. So we're going to be stateful basically. So I will show you some details about the deployment. So again, this switch. Right, so we have, I think that is going to be easy if I do the item and I create these, so then you guys can have it. Right. Okay. Yeah, right. And so pieces that we need to take care about here are, as I was saying, these guys splitting, and I'm going to show you this. This is stage one. So I've created a number of branches representing each of the steps that you will have to be basically doing, and then you'll do a QCat or apply, and then everything, all the magic rocks. So we have on the specs, under the specs, each of the components deployment files. So at this point, we need to talk about the stateful set Kubernetes object, where we basically need to consider a couple of things. So I'll talk about extra stuff that we need to consider later, but what I'm going to do is, here we go. So we are running basically Elasticsearch 6.7. One, we are setting up some Java stuff. We are deploying just the one node in the cluster. And in terms of the configuration, it's very straightforward. We just basically need to specify the cluster name and the number of nodes, and that's it, okay? So we got right now rolling Elasticsearch here. And now the next step is to deploy the next piece, which is going to be Kibana, all right? Could you please tell me how bad or good we are in terms of timing? So then I can, because otherwise it's going to be, yeah, but how we've been like, okay, 20 minutes, and we go 25 more minutes. Okay, I'm going to try not to go very fast, but we've got to go fast, and then we can talk later. And the code is all publicly available, so you guys can download it if you want it. So right, next piece is Kibana. So Kibana is going to be the same. Basically, we're going to have a deployment. We just want the one singleton, let's say, and the configuration is very straightforward. I will jump onto this one. I'm just going to install it very quickly. Right, so we just basically deploy Kibana, so it will get alive in a minute, and then we continue onto the next piece, which is going to be, right, what is here for? So the way that the beads are working is that they are collecting information, different kind of information, and we will go through each of the beads that I'm using. So the reason that's why we've put in here an event processing, a Kafka guy, is because we don't want to bang a logstash, and we want this guy to do the back pressure for us. So we will basically will have all these beads, throw in the logs to publishing the information to a different number of topics. And then we've got logstash configure, which is subscribed to this topic. So he will be collecting bit by bit this information and then writing or outputting it to Elasticsearch. So then we can have Kibana consuming that. So we are not creating an HA solution, but it's very easy to use. It's an stateful set, but we will roll basically one instance of Kafka and one instance of Zookeeper. Right, and I'm going to deploy very quickly, and I will. So this is now stage 3. Right, and we have Zookeeper. So there's a dependency. Zookeeper is basically managing the quorum. It's like the etcd and Kubernetes-ish. And then we've got Kafka getting his configuration and his cluster state out of these Ps, right? So this will get deployed. And get back to here. Right. So as I was saying, we got bits that are not just yet deployed, but we'll be in a minute. But we got right now this piece is configured. I don't know why. All right. So we've got Kibana deployed, we've got Elasticsearch deployed, and we've got these guys deployed. So the next guy into play is going to be logstash. Right. So I go to stage number 4. Yeah, I'm jumping a bit on the configuration of the deployment files because probably we don't have that much time, but we can discuss them later if you guys want. Right, so I'm going to check out stage 4, right, and then I'm going to run this guy, right, and this guy will deploy now logstash. Okay, so I'm going to show you configuration of logstash because I think it's important. Here's here. What is it here? Right. So we've got logstash. So remember that we are using the bits, excuse me, to send the logs to Kafka, and then we've got logstash consuming from those topics. So we need to obviously configure logstash to read from Kafka, okay? So how do we achieve these? By using different types of inputs. So as you can see here, okay, we have a number of different topics that we are going to be creating for each of the bits that are sending the information. And so we'll have one for each of the bits. And then we will have, if we wanted to have any pre-processing, because we got a number of microservices that we want to process information using Grok. And then at the end, we'll basically send that back to Elasticsearch, right? So now we've got this guy is rolling. So we haven't just yet created Kafka, and Zookeeper is on the way, and then we will have logstash in a second, right? I think that, yeah, rather than right. So we have deployed. So we deploy Kafka composed by Kafka and Zookeeper. We have done the same with logstash. It's also on a stateful set guy, and now we're going to be deploying the first file bit. But before doing that, we are going to see what we got right now via Kibana. Okay, right. So I've got here my Kubernetes plugin for this guy, and I'm going to basically get the dashboard running. 1 second. Right, and we have created our namespace called Elastic. And it's just because this is undergoing. This is an event loop, so it will converge when it's get done. And so we can see that Kibana is up and running, and Elasticsearch is also. So we can go to the UI. So we go to services, for instance, and then we go to Kibana, right? And you guys use Elastic and Kibana and on this stack, have you? Are you somehow familiar with the UI? Is that yes, yeah? Right, so the first time will take a bit of time. So we don't have any data just yet, which is expected. And stuff that we have pre-configured, which is basically coming out of the box by having Kibana connected to Elasticsearch, is basically the ability to see what's happening in Elasticsearch. So basically, we go to management, we've got nothing here. We don't have any index. We don't have any index management, but we will have access to the monitoring side of it. And I will discuss this later if we've got any time. So just basically bear with us for the 1 minute. And we will have to get, so we don't have any information, as I was saying just yet. So we are not able to discover anything. We don't have any dashboards installed. We don't have anything, right? So, but the one thing that we have by having a Kibana connected to Elasticsearch is, oops, this is the live demo effect, right? Is it running? There we go. Yeah. So we have in here, out of the box, an overview of what is happening on our unique instance of Kibana. And we can see here, we don't have just the one request. So we got here some entries. We see the name of the instance that is running, how it's behaving in terms of latency, response requests, memory, low average, etc. I'm able to click onto here and also to see some information just by the sake of deploying it free. Yeah. One of the things that we were somehow overwhelmed is the amount of information that Kibana is showing. That somehow we were basically saying we don't know what this information is. So you need to be very expert on or knowing what information are you expecting to see, because otherwise you will get like overwhelmed. So yeah, this was the piece. So we also have the Elasticsearch view. So yeah, more information over here. About the nodes, we have just the one node. That's why we have just the one instance, but we should be able to see the status of the cluster if we had in place. We can go to this guy and check in the Java heap, memory indexing time, CPU, system load, blah, blah, blah. A lot of information here, but doing nothing, just deploying the stuff. So we can highlight the GC, the garbage collect counts and latencies, a lot of information, as I was saying. Yeah. Okay, so let's get back to where we were. So let's see how the cluster is now, right? So now it looks like we're good. Okay, we have the ProElastic, then Kafka, sorry, a Kibana, then we've got the piece in the middle, which is a Kafka and Zookeeper, and then we've got logstash. So everything seems to be up and running and well connected. So next guy on the run is going to be, I think I'm going to be using this view if you guys don't mind. Otherwise, the switching is going to delay us a bit. So file bit, correct. So we're going to be now deploying a file bit. So we go to the switch to the stage 5. Cool. We deploy this folk, this fella. Right, we got here. Right, we got automatically having in place the these guys are diamond set. Right. This is important. Why we were having this initial slide about how we were historically installing the agents by SSHing onto the VMs, by installing stuff, this was somehow a very manual thing to do. And what if we have a number of VMs created? We have to do this process like n times every time. So one of the good things about Kubernetes is basically they have an object, an API object for each of the requirements. So in this time, a diamond set is the key here. So diamond set is the way of telling Kubernetes that I want one guy running per node. By this way, I can hook to the information that I want to collect. So in this case, we want to collect containers information. So we just need to make sure that we are mounting the socket for Docker, so that he can go into the details and retrieving those that log information. Okay, so we have deployed this guy. I'm just going to check the logs if he's hunky-dory. So this tool, this K9S, is amazing. So we've got here, and well, to put information, he has somehow connected to a Kafka, which is the front runner for us, and then logstash will have pulled that information before putting that back into Elasticsearch. Good. Next one. Go here, nice. Right, so we now can go to here, and basically we should have now our new index template, our new index in Elasticsearch. Right. So as you can see, we got this guy here, and now we have started to retrieve information from each of the containers that are running as a workload in our Kubernetes. So this is default. I also check that I have created a new index on Elasticsearch, and I can go to discover. And so yeah, I will show you in a minute. Information, very cool information that we are retrieving out of the box. So we are basically gathering metadata information for each of the components that are running on Kubernetes. So as you can see here, we've got host-related information. That's basically by adding that annotation onto the configuration. We also have Kubernetes-related information free out of the box by configuring so. And then we got the message itself. Yeah, and we could have used logstash to parse this guy, so then we can have more a cleaner, an easier way of understanding it. More information that we're getting, the metadata related to the cloud provider that we are running our workload on, which is Azure AKS. Yeah, we're running this on the west, on this region, this AZ, and we're running this type of VM, the cluster name, blah blah blah. There's a lot of information here for free. Cool. We go to the next guy that is AuditBit, right? So AuditBit is a kernel functionality that allows me to retrieve information of what is happening onto the system. So this is a feature probably that we can discuss later because a lot of information here, but we'll basically jump onto the deployment of it. And so yeah, we go into here, and then okay, we've got a new guy on the run. Yeah, show up. So we got AuditBit, and now we are going to be potentially. I'm going to review with you very quickly some of this information. Is here. Actually, I'm going to put this in here. Right. So come to here. We got specs. So as I was saying, every daemon is going to be deployed on Kubernetes using a daemon set, as we were discussing before. So we can guarantee that each of these agents are running per node. And configuration that we are highlighting very quickly is here on the config map. We've got the output to Kafka, we've got setup to Kibana, and then we have the number of modules that right now this guy from Elastic are supporting, which is basically file integrity. So it's checking that no one is accessing to this guy's paths. We also have information, so data set information about system host logging. So who is logging onto my system, what package, a process, or user is downloading, what user is logged in or has done something in the system. And also on the other, so this is a very cool one. So if we were about to SSH onto a container and we were about to change the password for whatever reason, we will get a notification of it. This is crazy, right? So we can go now to the audit bit. So we go to the indexes, and now we can see that we got a new index in place and index template, and we've got another index on saying the wrong thing on the Elastic, and then we got more information here that we could use. But we have deployed this piece, and we have also set up a number of templates as dashboards, so then we can consume this information. And this is basically pre-configured by the templates of the piece. So if we go to dashboard, for instance, and we type audit, I don't know, let's say audit overview, and then we're going to have I don't know, this guy. Right, so we've got pre-configured by us, well, by the product obviously, but a number of widgets that are basically visualizing this information. Yeah, it's probably difficult to see out there, but as I was saying, there's a lot of information, and we will need to probably have one session per product so then we can maximize the understanding of what I'm trying to achieve here. But as you can see, it's a lot of information coming out of the data shipper, and this is the same. I mean to have done. So for instance, Yeah, file integrity. So as I was saying before, it will tell us if a process or if a user have modified any of the files that we have added before. So yeah, there are some chunks of information that are not coming because we haven't produced that event just yet, but all is coming and in a very nicely way. Right, so let's go to the next one. We are now on 7. Right, so we've got stage 7. Now we are deploying Harvey. So Harvey is a very practical. It's a very good feature that basically is allow us to ping services so then we can determine or understand if they are up or down. So just basically, we need to configure which of the services we want to basically be pinging on, and then we can get that information through a very nice widget. So I'll show you in a second. So we are deploying this guy. He will get alive in a second. So very, in terms of information of Heartbeat. So I've configured to have monitoring these 3 guys. So we are monitoring Elasticsearch, we are monitoring Kibana, and we are monitoring logstash. If we have a number of services, we just basically have to enable a health check, so then we can ping it, TCP, ECMP, or HTTP. So we have enabled 3 HTTP monitors here. Well, but the product enables you to use different protocols as well. Alongside Kafka, well, this is like typical. We also have the monitoring, which is the feature that we discussed at the very beginning, which basically is going to show us where we are. Here on the monitoring side, we are going to be having, so we have the Elasticsearch, we have the Kibana, then we deploy logstash, and then now we have deployed the first, what we call now 3 bits, file bit. Sorry, second. We've got now file bit, audit bit, and Heartbeat. So we have these 3 guys here, and we can basically navigate inside and see how they are behaving in terms of CPU, memory, and so on and so forth. Cool. So we have deployed a Heartbeat. I'm going to just check that there is so Elasticsearch is at near real time, and that's funny because you think sometimes that it's not working and then suddenly it shows up. And we have added this Kafka thing in the middle, so we are adding some latency before the data is basically added to Elasticsearch. That is very important to remember. So we've got here a Heartbeat index. Is that created yet? Yeah, nice. So now we can go to this new section here called uptime. So this has been introduced in 6.7, not in 6.6. That was funny. So this is a new feature of this release version, and as you can see here, we've got we've got the 3 monitors that we have declared before, and now we've got the services are up, and so on and so forth. So this is also very useful information to have in place by just deploying this piece of functionality. Cool. Where else do we go? Now we jump on to number 8. And so we were on audit bit, then we deploy Heartbeat, then we have deployed, now we are deploying packet bit. So packet bit basically is like a white shot. I don't know if you guys have used this. It's like a network sniffer. So it just basically will tell us what's happening in terms of network packages throughout the control panel. Okay, so again, is our daemon set because we need to guarantee that each of the nodes have this guy installed. And in terms of configuration, let me remember. I think that we did configure here. Right, so this is the processor that I was mentioning to you before that are coming out of the box. So as you can see, I'm potentially resolving to DNS queries, and also I'm monitoring to using HTTP protocol to this number of ports, so on and so forth. We would just use these 2. And also we are enabling the flow, so then we can see different flows throughout each of the components of our deployment artifacts. Right, so we have deployed now. Sorry, I'm going too quick, I know, but I'm sorry. We just need to, so yeah, that's number 8. So we have deployed a packet bit, which is running. And now we're going to be, so by deploying these, we have installed the packet bit dashboards. So we can go now to Kibana. and onto the dashboard side. And then we should have here the packet beat related widgets. So for instance, this guy, I'm not able to cover all the scenarios, but this functionality is super crazy. I mean, super good, because if we had in place any MySQL, Postgre, Mongo, or these supported modules, we were able to trace what's happening from end to end. This is a very, very cool feature. And also, we are not geolocating, we are not passing the IP from within the logs, so then we can see where these jumps or connections are going in and out as well. So that's why this is empty. And a number of features that we are not basically having information to show from. But yeah, as I was saying before, it's a lot of information to spend time covering each of those. This was the flows. Yeah, I found this out yesterday. It's basically IPs. Yeah, because we are cluster IPs. We see here. We should be able to also see the names of the services. But yeah, this is showing us information from 2 different services by IPs and the source traffic. So we could basically spot any potential bot usage in terms of the network from within services. Okay, what else? We go for the next one, which is 9. So let's take 9. Oops. So the next guy is a metric bit, right? The reason that's why this guy is the last one is because metric bit is composed by 2 separate components. One component is the one that is going to be retrieving these, let's say, typical monitoring CPU I/O of this, I/O of network, and so on and so forth. And then we've got a different piece deploying to Kubernetes, which is the one responsible for asking the API server of Kubernetes and checking the state of the deployments. Do I have enough resources? Do I have enough all the pods that have been deployed? etc. So we need to rely on a Kubernetes piece called the Q state metrics, which is a separate module that we need to install as part of this deployment. And so we did, we did deploy number 9, and number 9 have all these guys. Cool. Right. So now we should be able to go to the next view on Kibana, which is this guy, infrastructure. As I was saying, it's near real time. We've got to wait just a very, very quick second. So when we have this problem of, I don't know if we are getting this information, first thing that we've got to do, if we see if the information is on Elasticsearch. So that's the first thing to do. So before doing that, I just need to check that the index is created. So we see here the metric bit. So now it's created, and now I go to Elasticsearch, and now I see here the metric bit index being created. And now I just basically need to, oops, this machine learning module that we are not covering today. Infrastructure. So now we're going to have like 3 different views. We have the host monitoring side, we've got the Kubernetes monitoring side, and we've got the Docker. I think I've got enabled Docker. Yeah. Anyways, so I click here. Imagine our cluster composed by 3 nodes. I will have here 3 different entries that I can basically navigate and check for metrics inside. So I could see like CPU usage. It doesn't have information just yet because it's just been deployed, so it will have to refresh in a second. And the load and memory usage, network trafficking, etc. And we go for the next guy, which is Kubernetes. So I can see here all the different pods that are running onto my system, and I could potentially see, oh, okay, I got a funny one. I got Elastic, which is consuming 50% of it. Let's see what's happening, and then you can tell me, yeah, CPU, memory, and network trafficking. What else? Well, can I get here? And also in terms of the containers as well, we'll have here all the container information. Right. Cool. What else do we have? We have the next guy, and the last bit of information is going to be the APM-server, which is the way of, if you guys remember at the very beginning, we started off monitoring, logging, and tracing. So this is the tracing module provided by Elastic. It's composed by a server, and we need to use an agent that is basically, it's not that intrusive. It's not intrusive, as for instance, Azure Insights and so on and so forth that we have been dealing with. It's very painful. I will show you how you just basically run the Java process with the Java agent jar, and that's it. And it will start collecting information for us. So let's deploy this guy. So this is number 10. Oops. Right. Okay, so we've got 10. Right, so it's going to take a bit because the survey won't take that much, but that's why I had this slide here. The way that the demo that we're basically covering is by having 2 Spring Boot microservices, Java, they're running a specific version of the agent that is configured to be pointing to the APM server. So then the APM server is basically managing all the observability details. So I'll show you in a minute. And this guy will basically throughput. This is not totally right because APM throws information to Kafka, and then we've got Kafka logstash writing to this APM related information to Elasticsearch. So I'm going to show you details of, so these guys obviously are containerized, and well, you can see it, but anyways, so this is the jar itself, and I am downloading the jar, the agent jar, and then I'm basically running the process internally in the container, attaching the Java agent binary, and that's it. And the second bit that we need to consider is telling at runtime where the APM URL is, so then it can find it, which is basically the second chunk. Sorry, folks. I can show you from here. So we've got onto the diamond set, which is the recommended way of Elastic. I'm not pretty agree with this, but anyways. So we got here to the APM server. Yeah, okay, the information, right. I don't see here something weird. Anyway, was expecting to have seen the information, I don't know. Anyway, so we now have the APM server, so just to make some time. How are we doing on time, Emma and Janko? Passed? Wow. Right. So, okay, just let me, the 5 more minutes to go through the lesson learned. Sorry, we started. Right. So, okay. Right. So, yeah, don't have that much time. So then I will jump this section, which is a shame, but I can show you that offline. And so just to end the presentation, so things that we should be doing next, which is basically enabling the high availability of Elasticsearch and the high availability of the Kafka. How we will do these? By having a layout similar to these. The product Elasticsearch is very easily configurable on HA by having a number of a quorum of masters and a number of data nodes, and then we'll have a number of clients that are stateless. So this guy is stateless, and then we've got it to stateful. And that is the flow of communication. And if we were to do the same with Kafka, we've got something similar. We've got to have a quorum of the brokers down here that were stateful, and the same, the quorum of configuration with Zookeeper. Right. What did we learn big time? Elastic documentation rocks. I mean, I'm not spoiling here. It's just very, very, very good, documented all over the place. I had a number of problems that I went to the forum, to discussions, and I posted my questions, and they right away helped me out, like very, very quickly. And we also found a bug on the APM server thingy. That someone from your company help us on figuring what was going on. So that has to be said, the documentation. We have the documentation also help us on pre-configuring Elasticsearch on a number of steps that you have to do, as for instance, the configure SysTCL that we'll have time for. The storage class is also something that we learn because on Azure by default, it'll use a storage class that is not SSD compliant. So we have to create a specific storage class and then hook it up to those stateful sets. Another thing was so when you don't have Kafka in the middle and you deploy each of the bits, by default, the output is Elasticsearch. So they will automatically configure all the boilerplate for us, the templates and the index templates and so on and so forth. But because we put in the middle a Kafka, you have to hook or do a bypass of that configuration. So then you roll out the configuration, and then you have an asynchronous job that is basically stopping the output to Kafka, going to Elasticsearch, and then re-enabling it back. That is on the code for you guys if you want to say it. And the very last thing, very quick, sorry, Helm. Do you guys know what Helm is? All right. So on Linux, you got like on Ubuntu, how you install a package using apt. On Red Hat or on CentOS, you do Jump, or on Fedora, so on and so forth. So in Kubernetes, the way of packaging packages is Helm. Okay, Helm 2, and now they have created Helm 3 draft is out of the way, so it will change a bit the architecture. It will be client. It will be client only, no server. So for us, what we did was basically going to these repositories and getting the Kubernetes descriptors, and then from there we were able to modify them a bit before deploying them. Okay, sorry about this. Very quick. I'm sorry, and I think that I'm done.